first people dealing with viruses in Hungary, and he's going to describe the ancient history of virology here. Hi there. And I'm really one of the old guys mentioned here. My story doesn't reach as far back as Pisti Szabol's a few moments ago, but I think a lot of time has gone by in this field, and that a lot of time means that we began 22 years ago, approximately. The very first virus reached our hands in the autumn of 1988, and I'm not giving you a big secret, but I used to be a military officer at the time, and I was part of the IT division of the military. We were in charge of the Budapest and the surrounding regions computers, and there were mainframes, R55, as my friend Lajos mentioned. But we had lots and lots of PC category machines to repair as well. I wonder if you can imagine the situation. Let's say a lady calls in and tells us, listen guys, the letters have begun to fall off the computer screen. And you know, we opened our eyes very big and we said that this was impossible. And the service van drove off to fetch the computer, and we began to test it, and lo and behold, letters truly were falling off. The fact that there might be a virus somewhere out there in the world, well, that was hearsay. We had heard about it, but we had not seen any. That was the early autumn of 1988, and by the end of the year, if I remember well, we had 3 active viruses alive and kicking. And we were in a pinch. It was very embarrassing, because I wonder if you know what the COCOM list was. It was a very strictly enforced ban on the delivery of IT equipment, including PCs, to the Eastern Bloc, along with the operating system. And obviously, various components reached the country. Many computers came in, and these were 8286 category machines. And they were obviously not subject to the original IBM copyright, because IBM strictly enforced these rules, but other vendors did not. So we had other vendors supplying Hungary and the Hungarian military, and the letter drop-off virus looked at the BIOS, checked the IBM copyright, which of course is still inside the IBM original equipment, and if the copyright was found, it just quit out of the computer. And if it didn't find the copyright, the letters began to fall off. Let me just add to the COCOM list that it wasn't just a ban on the delivery of electronic equipment, but also a ban on documentation. So in Cascade 1701, we began to do this without documentation. We knew nothing about the BIOS or just a few published functions of DOS, and of course the virus wasn't using those, otherwise it wouldn't have been a virus to begin with. So we had nothing to rely on, and 2 colleagues and I cracked the Cascade virus using machine code manually. So we reverse engineered the code to crack it, and the first breakthrough occurred at the following date, February 1989, with the reboot virus. It was a simple virus. It kept rebooting the machine. Just a bit later, toward the end of the year, we had Friday the 13th, Panic Day. And we were prepared in many ways, and we had a major software-based background for finding it, and we believed that we were doing the right thing, and we would actually remove and kill the virus. But neither the news nor the faith reached the appropriate quarters, because believe me when I say that it was incredibly hard to convince people that indeed there is such a thing as a computer virus. The truth is, speaking of stories, imagine this. The phone rings, there's a female doctor who introduces herself at the other end, and she's very pushy and trying to convince us that she has access to everything. She can even access an electron microscope, and let's take the machine to her and she will inspect it. And I swear to you that this was the case, because people had a very hard time digesting the potential existence of intelligence that can reproduce itself and do similar damage to biological viruses. I can't even begin to tell you how hard it was to make people understand that this thing was really out there and threatening. About a year went by and we had about 200 living viruses. Living virus, in my examples, always means that we have a copy of the virus and we can make it work, bring it to life, in other words. And, you know, we were depressed by this lack of belief in the idea. I only made one phone call to a radio show in all my life, but they were explaining to the public that there was no such thing as a computer virus, and people believed that there indeed wasn't. And we had a floppy disket's worth of viruses, and so I could tell the guy that, believe you me, Mr. Reporter, that if I gave you this floppy diskette and you inserted it in your computer, it would never ever work again. Now, the first book was released, the first in all of Eastern Europe, trying to provide an overview of computer viruses and all we knew about them. Unfortunately, due to the pressure exerted by the publishing house and due to other influences, to put it in a simple way, unfortunately we couldn't publish a good description of the code or how people were making viruses, because, well, the powers that be at the time would not allow us. And yet, a description of about 85 viruses could be included in the book, and we developed a typology. We classified the viruses in the different categories, so 85 viruses explained in detail. We described in the book how you could scan the computer and how you could detect a virus, how you could immunize the machine. And the purpose of me and the co-authors, of course, wasn't just to show off and start bragging. And of course, we would provide a description of working antivirus programs that could scan and remove the viruses from computers. And I should also mention my colleagues, Gábor Endridi, whose name you could see in the previous list. He was with us from the outset, and János Kis from Szeged was helping us writing the descriptions, and Imre was helping us to develop the scanner systems and so on. And the competition a few years after us also came on board, and Dr. Lejtóth Ferenc developed Checkvir, and Gábor Szappanos developed Virus Buster and still maintain it with a team, and Péter Szőr on behalf of Symantec is a great developer today, and he wrote a book that was published about 5 years ago in the US on this topic. So that was the fabled past. And now I'm going to attempt something no living soul has ever attempted in public, at least not that I'm aware. I'd like to tell you why we changed tack, why we changed our philosophy. And everyone is still pursuing a certain approach, and we diverted our path away from it. Just think about this. By the end of '91, we knew about 1,500 viruses, and we had about 1,200 of them cracked. And evolution, or development, if you can use that word to talk about man-made programs, algorithms, evolution was incredible. However, most viruses were not original creations. So instead of Friday 13th, they would say Tuesday the 8th. So they would just take an algorithm and hijack it. By June 23rd, when we were writing this book with the colleagues, we had about 1,000 viruses coming to life, and we had a hard time keeping track of them, cracking them and finding it inside their mutations. The ingenious author would alter the content somewhere, but we didn't have enough time to find out where.
So we should handle this situation and implement this situation in an up-to-date way.
Lehetetlen. Gondoljatok meg, nincs internet, nincs egy webszerver, ahova be lehet jelentkezni, vagy egy bármilyen szerver, ahova be lehet jelentkezni, és letölthetem saját frissítéseimet.
So those who ask for it, bought it, and it doesn't matter which kind of software it is. From this, it followed that somebody always ran into problems, because those who received it first, we get hold of it from him. There were some virulent viruses that spread very quickly. And then there were people who sent floppies with information on AIDS, and then they actually infected old systems. And we started to think about the following solution. If there is anything, any similarity between biological and computer viruses, a simulation of a living matter is a thing, but can we find similarities, connections, properties to compare the biological viruses with computer viruses? Is there a viable model? And if we did this, then can we draw conclusions from which we can really learn from human virology? I spent lots of time at the Virological Institute of the Hungarian military. I did not become a virologist, but I learned a lot about viruses. And for example, I saw the Quran in real life. And after these studies, we wanted to compare living viruses, biological viruses, with computer viruses. And I must tell you that we found reasonable things, meaningful things for comparison. One thing is that they are extremely small. A flu virus is invisible to the naked eye, and the MS-DOS average size was 25,000 bytes, and the virus was something like 31 bytes from 1,000 bytes. So these are small, and if you really just calculate interpreter programs, then we go up into the region of 100,000. Both viruses can only live in a given environment. If a hepatitis virus is taken, then a dog won't have any problem with it. But Babesia virus doesn't do anything to cats, which is life-threatening for dogs. But the same is true for computer viruses, because there is one instruction set for PC, there is one command set for MS-DOS, and the functional system is the same, and it is possible to write viruses for MS-DOS environment, but they will be two separate code, and it can only live on in this environment. Biological virus is a DNA chain. And if something is infected, if an organism is infected, then it will just change a part of the cells of the infected organism. And whenever the cell is proliferated, then we will just spread the virus. The same happens in the computer. If a program is considered as a cell, then due to the infection, the program is forced to spread the virus. And then it will deal with the functional part of its task. Both exploits its own environment. It's quite natural, and it comes from the microscopic properties. A biological virus cannot really go and do things and breathe, because then they would leave traces behind that a man would immediately notice. Uses those functionality, BIOS functionality, it doesn't have a disk control part. It encrypts something and then asks BIOS and recodes something and infects the whole system. There is a very important thing. Both of them are undetectable by our senses of perception. And the computer itself cannot perceive it. And there is also an important thing, this is incubation, latency or incubation. So all the malicious program looks like a bullet or an arrow, more like a bullet or an arrow, which causes immediate problem, which causes immediate harm. But viruses always have incubation, and they would like to proliferate, and for this they need a real incubation time. They should be hidden from the naked eye of the observer, and this is incubation. This is what we get hold of, to really just get hold of the incubation, to notice it in time. What would happen if the human organism were noticed from the moment when it is infected? Our society would have built quarantines in the street, and other people would just step in, and they would very immediately stop the proliferation of the spreading of an epidemic. So what comes out if I could reduce the incubation time to 0, then one given machine, one given program can be eradicated from the system without letting the epidemic spread. It won't be any computer-related death as it happened in 1986. We learned from the biological viruses, and due to our learning, we thought that we were in a lucky situation because we exactly know how a program should look like, or what a program should look like. Well, why can't we immunize this program? Because we can write codes that would check the first instructions of the program, takes it whatever it finds here, puts itself at the end of the program, says the program to start with this, checks if everything is clean behind it, and if there is something there, then he will just delete it. Cut it out, puts it back to the beginning of the pastes it back to the beginning of the program, and the program is solved. The virus is killed. At the same time, of course, they may tell the operator that there was some swindling, some mischief here. This solution wasn't really lucky because there were codes that protected themselves, which had some control number algorithm, and they didn't tolerate immunization. And it actually produced a placebo effect on the users. And if everything is immunized here, then they didn't deal with the messages in a given case. At the same time, we learned the whole thing as we have learned from the viruses how to do it. Other virus detectors may mistake it for a virus. The self-defense part may mistake it for a virus because they contain illegal instructions or semi-illegal or unusual instructions that even a beginner heuristic algorithm would regard as a virus. But we minimized the incubation time, radically minimized the incubation time. Those systems where similar solutions were used, and not only viruses were looked for, they couldn't completely fail because they gave warning much beforehand, much before that. I don't know if it occurred to you, but I never mentioned the name of this or that viruses. Like Friday 13 and so on. Now I am speaking about the viruses in general, and this is a change of philosophy. So we shouldn't find computer viruses. I'm not interested in flu A, B, C virus when I have flu. One thing is important, health, being or staying healthy. And at that time, we believe that we can really achieve this. The last slide of the presentation, or the last part of the presentation, would like to share with you a solution which operated, functioned, and then it was lost. That's the lost solution. Many firms started to find out a hardware-based solution. Simply because no software solution survived the hand of Gábor Endréti or Szegedi, either their hands or their wit. We could really switch it off or turn it around if there was a hardware device. There was one thing that we could do, and many of us attempted this to do. We prepared a hardware device that cannot be switched off, only if you just dismount the whole machine. The basics of the whole thing is as follows. We should really grab all kind of knowledge and opportunity to check our programs. What happens with the scanner softwares existing all over the world? We should try to determine what kind of compiler it was used, Boland LP, C, C++, and so on. So if a code starts as it was translated or compiled by lattice C, then we can say it's clean. we should do our best. We should use all the resources. And then as soon as we know how the starting environment should be checked of a program, then we should store unique identifiers of the program. Not as we did in the case of self-defense. We should really take it off from the shoulder of self-defense, and we should store it in a database or any storage device. Third thing, very important, we should install a small module in each PC that oversees BIOS-I operations, BIOS bootloading, DOS file operations, application launches. And let's say that the results can be given by programs that have real classification, registration. Unknown programs cannot enter the system and cannot run without classification. Archeck programs cannot run even if they are clean. Often they contain viruses. What happens if we failed to recognize the virus? The answer is nothing. Why? Imagine you have 100 programs. Assume this, and all of them have some characteristic feature, and the 101st is infected. We try to evaluate it, classify it. We check the entry environment of the virus. It will start. One is infected out of the 100. Will it start? No. We will get a warning. Incubation time is 0, and there is only one program which was affected, which seemed to be okay. And there is one in the infected one which seems to be bad. But if we classify it, then it is identical with the one that seems to be good. We can use it for analytical reasons. So there was an automaton of comparison. The objective was not to find the virus, but to keep the whole thing healthy. Somebody may say that this is hardware and very expensive. No. At that time, on every Ethernet card or board had a remote bootleg. And then it was just built in, remote EEPROM. And what was the consequence? Around 95, 96, many companies, hospitals, secondary schools, which is a very dangerous area, and not even a single virus could destroy a big epitome. We could catch certain viruses, but hardware developed, Windows came, and the whole world came to a standstill. Thank you very much for your attention. And there is one question. Maybe I will be the person today who will ask you a very ugly question. These are the prices for these things. And we mentioned boot virus. Can anyone tell me what are in the last two bytes? Why is the last 2 bytes 55 AA for a boot sector? Why it is 55 AA in hex for the 2 last bytes content? That's the content of every boot part. We know that it is 55 AA, but why? Why? What's the use of this? End of a boot sector, 55 AA, no. Another attempt. Calibration, no. This is something much farther away. And I was just consulting myself if I really should dare to ask this. May I give you the answer? You know that at the beginning there were 8-bit computers, Commodore and Z80 and so on, and Spectrum. And IBM decided that he will do a big machine in which there will be 640 kilobytes of memory, active operative memory, and the rest was used for the video, the BIOS, and everything else. XTs were made of 1-bit memory chips. That is, a memory module had 9 chips next to one another, and in each and every there was 64 kilobit. And the whole thing was constructed, and the reason why 55AA is the last one, because the BIOS must be loaded within one existing chip, and the likelihood that the memory chip will fail, instead of turning everything around and even the parity bit is false, and then the next line in it will just fail in the opposite direction, then the likelihood is 2 to the power of minus huge number, and this is the reason why 55AA are the last 2 bytes contents.